Welcome to CES 2026. For Tianma, we have a bunch of new displays. We'll be talking about the micro LED, flexible LEDs, splice technology, seamless technology, color BCN. So I'm going to start here at our OLED devices. There's 3 OLED that have similar resolution, similar capabilities, and what's different about this is a stacked OLED device. So it has 2 LEDs at 2 layers on top of each other, so you get higher luminance, better efficiencies of brightness, and power savings. So if you're running all 3 of these at the same brightness of 1,000 nits, it'll be 30% power savings and longer life. And you can see the colors here. The colors are really good. They're 125% of the color NTSC. This one here, which is different, it's a single layer, but we still get a bright color. It's because of the high purity of green color that we put in it and the more reds. So this is why it's the, and this is the traditional first launch of the OLED device. We're looking at this one, which is very similar resolutions and sizes. And this is a 6.7 inch stacked OLED. What's different about this, it is a higher brightness. So if we were to take the brightness, it looks like 2,500 nits, very, very bright. But at times we can take a small portion of the screen and bump it up to 5,000 nits. So great for sunlight readability user and very low reflectance on this. As we move on to the ultra narrow borders, these displays, you can see the difference. You can see the black line around them. The borders are getting smaller and smaller. And here we have, as of CID last year, we had less than 1 millimeter, including the edges. And this here has a new technology of driving. It's called our ADP, which is our Advanced Drive Pixel. So it has much more power savings. So it's got about a 13% power savings over the stacked OLED. This device right here, we have 2 LED LCDs under there, which are not on right now. But when we look at it, it's basically our eye-friendly technology because now it's all about human health. So this helps with preventing flicker because traditionally everybody dims it by doing a pulse width modulation. Because it's an analog device, we can actually dim it down so it has constant brightness, and it's very easy on your eyes, so less eye strain because you see more and more people using phones all day long. It's 6 points. This is our ultra-high refresh mobile phone, high resolution as well. And this has and then we have our other device here, which is another mobile OLED device. But what's unique about this one, it has a black mask in front of it. It helps with preventing other users from seeing you. So if you're direct on, you can have great visibility. But if you get off over 45 degrees, you lose the image. So it's great for privacy. So here we have is our 108-inch world's first mass transfer of OLEDs, micro LEDs. And these are lasered on. So this is the world's first largest display. And we're doing the laser onto the glass substrate. It allows us to be about 100,000 times faster than the pick and place. Coming over here to our mobile panels, and we have 29.5 inch, which is 6K. So it's 6,000 pixels this way and about 1,600 pixels this way. It's a 1 LCD. It has 3 ICs to drive it, so very, very narrow border. And it has an EDP interface, so it's high resolution. It's about a 2 millimeter border around the upper left and right. It's a great panel this is targeted at the automotive market. So we're talking about our 17-inch, and this has a light control device. Just like how I talked about the mobile one device, it has a privacy. So in a vehicle, you want to prevent the ambient light or the LCD from showing up on the windshield. So we put a black mask so it prevents it from shining up here. So this is why we put this film up here, so you won't see the reflection on your screen of your automotive. And it also helps preventing the ambient light coming in through the windshield, preventing you from seeing it. So this is a great improvement over this. We have our 13-inch, which is our L-shaped OLED. And what is this? It's basically, we had a hot form glass where we actually bend the glass and we adhere the OLED device to it. So the glass is holding the shape of the display, and it has a nice bend radius here. So if you were in a vehicle, it's typically hard to reach the bottom part of the screen. By allowing you to rest your hand down there, it makes it much easier to touch the bottom piece. Well, we have our new one, which we're working with Corning on a new type of glass, which is hot forming. What is hot forming versus cold forming? Hot forming is allowing you the ability to basically build the whole display up as a flat structure and apply coatings, so you can do the anti-glare, anti-reflective, so you can see how great the blacks are on this display. And what's actually holding the structure, the bend, is the back plate here. So if we were to remove this back plate, it would go back flat. So this is a great technology moving forward. So we have our heads-up display, which is a picture-generated unit. We have a one display in here, and you can see that it's being generated. It's a reflective surface here. It's not through, so you have a reflected surface here. It's one, and that's a 43.7-inch ultra-wide viewing angle. And then we have our 47-inch, I think it's 43-inch. It's basically 3 displays on this. It's very similar to this one, but we actually use 3 displays, and you really can't tell that it's built into 3 displays. So this is a very thin. It's less than 15 millimeters thick for this display, and it has a color NTSC of 82%. So you can see how great the colors are, and the viewing angle is good. We limit the viewing angle up and down, and we increase the field of view left and right to 60 degrees. When we come into this display, this is our micro LED. So micro LEDs is a little different than OLEDs, so you can get higher color gamuts. And this is actually 3 7-inch to create our 19-inch. It's a seamless display. Because there's only about 0.20 micrometers difference between the edges, we can actually butt these up so it looks like it's one display that's 19 inches. Very good resolution on this for the display. Here we have our 3D display, and you can see that it has a couple of tachometers, and as we move around, you can see that the 3D, it looks like it's looking at you. I'm just going to move my hand so you can get an idea. You have to be directly in front of it. So talking a little bit more about micro LEDs, you didn't really get the chance to see this, but as a micro LED, you can actually see through. It's got about a 60% transmissivity. You can see my hand through there. It's got 102 pixels per inch. The reflectivity is about 2.5%, and the border is 0.1 millimeter around. So once again, it makes it really easy to splice this technology together. We have our 12.3-inch, which is a switchable privacy display. So this technology, it's not like the other one where we talked about where we put the black mask. It is an LCD, and if I was to move this, you will see that it'll disappear. We have a shared mode and a privacy mode, and what we actually do is we put another monochrome LCD in front of it, and when we turn that on, we can create a privacy or a shared mode. So Tianma has a 17-inch OLED, so it's a very wide display, wide view, and this is an AMOLED. This is a flexible LED, and right now we're showing it in the information mode. This display can be rolled up, it's got a roll down, it can be changed in the shape. And what we're going to do is we're going to show you it being rolled down. So it's going from information mode to entertainment mode. It's got a bend radius of 7.5 millimeters. It's great, so you can put it in the back of seat of a vehicle, have it come down for the kids to watch a movie in the back, or adults. And when you start driving, so it doesn't interfere, you can basically have it roll back up, and that doesn't impact the device. So what happens is, in this flexible LED, it's an OLED device, it's mounted on a foil or a piece of plastic. Whereas the other displays we talked about over here, they're mounted on a rigid structure. They're basically the same display, but it's the mounting, how you mount it. So, and here we showed it, the 17-inch, the same display, instead of it mounted coming down from the ceiling, it's now coming up. And this has a touch on it as well. So if I was to touch this button right here, you can see it rolls down from entertainment mode to information mode. So now it's not going to comply with the law. And we have our seamless display. The seamless display, so our armrest has a wood grain look feel to it, and you can actually touch it, and then you can see it has a low delta E, high transmissivity, so you can't tell if when the display is there, when it's off, and when the display turns on. It's great viewability, left and right. So you could put one display in there, a number of displays. You could have this on a wall. There's a lot of different places you could hide a display. And we have our Acronis display, which is a display here, which allows, we have a camera right here, we're showing the side mirrors, the view here, and so a lot of information for the navigation. And we have our round display, so it's our freeform technology, which is the breaking of the traditional rectangular shape. We can do that technology. It's very simple for Tianma. You may have seen a lot of home applications where there's a thermostat in your house, or you can make heart-shaped displays. We're not limited to just rectangular. Tianma's iFun display technology is proprietary to Tianma. What we do is we're putting an adaptive ambient light sensor. It also does color gamut. And if we're looking at these two displays, this is a traditional display without the ambient light as a sensor. And as you can see here, it's very difficult, it's very dark. With These are the same exact images, but because it has an adaptive ambient light sensor, you can now see the color green, and the coatings on here, the reflective surfaces, take out the glare. So it's much more friendly to the eye. Both of them are the same picture, but because of the technology that we have integrated on board, it adjusts the gamma as well. We have our 27-inch quad high definition display. This is an oxide technology. This is 610. This is the fastest oxide display. So oxide, it's a semiconductor process. So this is 2500 by 1400 pixel pitch, and it's 610-inch. And actually, that was the brightness is 610 lumens. It's got about a 1% reflectivity, so that's also helpful for the eye. You want to try to eliminate any reflections. And the border is very small. It's got a 5mm border around the edge. Great applications for gaming monitor. The most popular size is 27 and 34 inch. So this is a great display. So we have our world's first 16-inch wide QXGA display. It's 480 hertz oxide. So this is 2500 pixels by 1600 pixels and has a great refresh rate, 480 hertz, so it's very, very fast, great for motion sensor, so you don't see a blur if you're watching a game or a video, and 1200 to 1 contrast, gray to gray is 3 milliseconds, and it's got a very, very small border as well. Great for the notebook applications. And then we have 16-inch, which has a 1 to 360 hertz. This is an adaptive refresh rate. So by having an adaptive refresh rate, it has multiple benefits. The benefit being it's great for your eye health because you're not getting the flicker. Also, you're getting a power savings on this as well. So you're going from, when you're at 360 hertz, it's a 2-watt display, down to 1 hertz, it's now a 0.033 watt display. So significant power savings, and it's great. So it allows you a lot of flexibility from writing a Word document all the way to doing gaming. And once again, this has great color gamut. It's 100% of the NTSC, so fantastic display. Then we have our small mobile type of displays, but these have a very high definition. They're full HD, which is 1900 by 20 by 1080 pixels, and very, very small border, 5mm border on these displays. Great viewing cone on them as well, and great refresh rate. So we're looking at 60, 90, and 120 hertz. So these are great gaming mobile displays. And this is an active matrix OLED, and uses 4 lines of MIPI because that's a lot of data and a lot of speed going there. This is the same display here, great for gaming, 5.98 active matrix gaming display, 1,000,000 to 1 contrast. So if you're looking at the blacks, these blacks are deep saturated blacks because the pixel is basically off, saving some power as well. We have here a 16-inch wide quad XGA display, which is with a 240 hertz refresh rate. So high contrast, smooth motion. It's a pretty very nice display here. And then we have, if you need to step back and you need to be at the right angle for this has a 3D, so we're looking at your eyes, and you may see this thing pop out at you. It looks like it's out here. It depends on your eye length, so you have the spacing of your eyes, so you need to push it in and out to get the right distance. And this is our light field 3D tablet. We have no loss of pixels because of the way we actually orientate the pixels. We rotate them, split them, so it's a pretty good technology here. And then we have our microfluid display. We're just setting this up, this computer here. If you can take a look in here, a microfluid display is great for laboratory work when you're doing experiments. Basically, you want to use small material and you move it around, and you can actually cause the interaction of the material. The liquid crystal material is actually pushing the material together at certain times, so you have better control. So it's a great process control. And then we have LCDs. Why would I use an LCD for communication? So what happens is, traditionally you would have to physically move a mechanical device to point it at the satellite. By having an LCD display, you could actually feed in a signal, and we have beam steering, so you could actually steer the beam and point it at the satellite. And then we also have a receiver, which will also look at the satellite, so you have to tell it where to point, so you can use beam steering, receive the information, and collect it. 17.3-inch narrow border integrated ALS. What does that mean? Ambient light sensor. So if you look up here, we're talking about the luminance and also the color temperature. There's a sensor built in, and it's integrated. When I say integrated, that means it's not a separate subsystem. It's physically built in. You can see that the color, the luminance is changing, and the color temperature is changing. So this is a 2800 by 1600 pixel display. Very, very bright, narrow border on this display, very narrow border. And I want to show you, I'm going to move over to this one. This is basically like a 1 pixel display. So for privacy mode and vehicle, these are all automotive. If we were to look at this, typically people would put a privacy film on it. With this one right here, we can adjust it. So it'll adjust it, and we can adjust it from black to straight, any shade from clear to a black. Whereas this one right here, because that's one large piece, we're breaking it up into 3. So it's not just one. We can actually break it up so you get privacy mode. We have 3, one right here, and we can use the 2/3 and then the full. So new technology. So Tianma is being a very innovative company developing a lot of new, over 40 new displays technologies this year. We have our plastic OLED. So basically being plastic, it's a very flexible OLED, so you can actually change the shape. This is a plastic OLED, very low power. And what's unique about this one, it has an MLP. MLP is a multi-lens pattern. So what happens, we put a bump in there and it causes the side light to be forced up, so you increase the brightness, so it goes into a high brightness mode. We have over here is our traditional glass OLED. So that's a rigid structure, similar to your watch. And then when we move on, we have Tianma's 14-inch wide UXGA display. If you notice this display, it has a privacy mode. When you get off at an angle, you see a different image, and then when you're in front of it, you can actually see the real image. So people, if you're sitting on a plane, won't see what you're looking at. This is a 1920 by 1200 pixel display. It's got a great privacy mode when you get off angle, and you can set up custom logos. And you can see this one already has a logo set up for it. And now when we get over here to our 14-inch, 2800 pixels by 1800 pixels display. It's a low temperature polysilicon, so it's very, very fast response speed time, high contrast. But the reason why I want to show you this display is because it has an in-cell pen technology. What does that mean? We take the touch technology, instead of it being on the top surface, we embed it inside on the TFT surface, so it allows it to become thinner and more cost effective. And because it's a pen technology, for artists, they can actually draw on it. Somebody decided to change the thing, so you can now draw on this. Somebody put it on fill instead of so now you can see, you can draw fine lines, much more control, more like an artist. And here we have our 16-inch 2080 pixels by 1600 pixels. This here has a really fast refresh rate. It has an integrated T-Con, so it allows higher efficiency by embedding more in the display. It becomes thinner. You don't have that PCB on the back side now. Moving on to our 27-inch, which is our quad high density display. That is 2500 pixels by 14,000 pixels, and it's a 350 nit monitor. So this is and it has adaptive refresh rate. So if you're using the monitor and you want to create eye-friendly, you basically lower the refresh. So if you're doing a Word document, it becomes easier on the eye. And if you want to do gaming, you can bump it up to 144 refresh rate hertz. And so it's got the adaptive, so it can be power saving mode depending upon the application. 27-inch ultra high def display. It's 140 hertz LTPS. That's a low temperature polysilicon. It's got a great refresh rate because of the polysilicon technology, and it's 4K by 2K, so high resolution, great for medical applications. So it's got the high contrast and high color gamut on this. And then we have our 23.8-inch. This has got a very, very narrow border, high resolution, full HD, 2000:1 contrast ratio, very small border, great for medical and HMI applications. Then we have our non-traditional shape. This is an extra long display. It's a 28.6-inch. This is targeted at our commercial market. Might be put into a transom of a train or a doorway or something. And this can also be used not only in the landscape mode, we could actually put it in a portrait mode. So we could rotate it 90 degrees, so it's got very good symmetrical viewing cone. It's got a high brightness. It's 1700 nits, so it's very, very bright, so it'd be great for signage and you can see this in this application is used for a train to show you as you're getting through train stops. Very good viewing angles, wide temperature range, minus 30 to 80 degrees C operating temperature range, and the resolution on this is 192/540. So it's basically a full HD, but you're missing the bottom piece. This here's our 13.3. We actually have this in mass production right now in our P series, but we're showing what we're doing to this technology, how we're making it better. We're using basically a mini LED. A mini LED is basically a backlight technology where it's an array of LEDs in the back, and we also combine it with a film that creates higher colors, so you can see the red, the green, and the blue, so you get a higher color gamut. And because it's an array, we can actually do dimming, so we can create higher dimming zones. We get 1536 zones, 1536 zones, and could come over here, you could see how deep saturated the blacks are. This is why we have like 1,000,000:1 contrast on this display. Excellent technology. This is why we could see this proving over OLEDs, because of it's a proven process technology, and it's great for the ambient outdoor lighting where over OLEDs. So this is a proven technology, great color saturation, low and power savings, because you're not lighting up the whole display, you're lighting up only the pieces that you want lit illuminated. This is our wet and glove technology. This is our 6.8-inch, which is an in-cell technology. When I talked about in-cell, it's not a touch screen on the top. It's actually, the touch is embedded into the TFT structure, so it's nice and thin and light. And we're dropping water on this display. I want to show you that it will work in rain conditions, saltwater conditions, and also with a thick leather glove. So it works in all different kinds. And it's using an in-cell technology. Less chips, lighter weight, and same performance. It's great. It should have a savings about 10% over the traditional, adding the cover lens on top of it with the touch. We're showing like what we did in the automotive. This is called our seamless display. If I was to turn the display off, the backlight off, you can see the white. When I turn it on, then you can actually see the display. This is not as good as the other one because of the Delta E, because this is a white. It's very difficult to do, but Tianma wanted to show you that we have the technology to do it. It's very difficult to do white. Black is much easier to do, and the wood and the space silver, but what we can do white. This is our 2.8-inch in-cell display. It's a quarter VGA. We're showing you that it has a touch. This is an in-cell touch. You can see that I'm writing on it. Great for medical applications, and a good operating temperature range from minus 20 to 70 degrees C. So as NEC is talking about higher integration, what can we do to bring more to you? And as I talked about, higher integration, lighter weight, easy to hold, less, as a customer's using this all day, this is a great for a POS application. We have a touch on this. We have a near field communications. Near field communications is if you would bring your credit card up, what you get within 2 centimeters, it's now reading the credit card. So it has touch, it's an LCD. It's got a resolution of 720 this way and 1280 this way. So that's an embedded display. Great for POS applications. Very lightweight. As the user's using it all day, you're trying to reduce their weight, and also adding films in front to reduce eye strain. Speaking of eye strain, this is our Eye Healthy display. It's our color BCN. There's no flicker, and the reason because it has no flicker, it's a bistable display. That means you write to it, and it stays static. It's not going to change. And there's zero power on this device. You could basically drive it once, and it's a reflective display, and walk away, and it's going to stay there forever until you write to it again. It's great for digital signage, for like a bus stop or advertisement, where you go in the next day or the next week and change the signage. And then we have it's got a great temperature range to minus 30 to 85 degrees C. So great signage, billboard type of application, or at a bus stop. And then we have our 50-inch ultra high def display. It can be used in portrait or landscaping. It's got a good temperature range. It's a 4K by 2K display, great for point of sale application, menu boards. And when we offer this new technology, we're going to be offering it with narrow borders. We're even getting the borders down from ultra narrow border to an extreme narrow border, so they're getting much closer, so you can start splicing this technology. I want to thank you very much for coming to Tianma's booth and seeing all our new technology. We want you to explore all the new technology that we're offering, and we would love it if you could contact us and we can help you with your applications. Thank you very much, and have a good year.